Hey everyone, here's a couple of examples from section 2.1. So we're going to start off with this first one. It says, find the slope of the graph f of x equals 2x minus 3 at the point 2, 1. Now if you know anything about lines, and this is a line, you know that the slope should be 2, right? So that's not really a big deal, and we could do that and move on, but that doesn't really help us with the whole, idea of limits and being able to use delta x and kind of simplify some stuff using algebra. So what we're going to know is we know what the answer is going to be, but now we're going to try and use it using this function. So remember that it's 2x minus 3, and what we're going to do is we're going to take all this stuff and put it in for the x, right? So what we can do is we're going to say that this is the limit as delta x approaches 0, and now we're going to replace the x's with 2 plus delta x. So I'm going to start with this 2, parentheses, replace the x, 2 plus delta x minus 3, right? Everything stays the same, this just replaces with the x, right? And now it's also going to be minus this part, f of 2, which is going to be 2 times 2 minus 3, and it's going to be all over delta x. That doesn't change. So all we really did was just move stuff into where the x is, right? The stuff that's inside here, we're just changing that to be where the x is. Okay? Alright, so from here, distribute, multiply, simplify, put stuff together. Okay, so we have limit as delta x approaches 0 of 2 times 2, which is 4, plus 2 delta x, and then we got minus 3, minus 4, minus 3. Right, the 4 minus 4 cancel out, right, and we should be careful about this, I'm sorry. The minus this should be minus the 4, but I should also minus the negative 3, which makes it a plus 3. There we go. And then these cancel out, and it's all going to be left with delta x in the denominator. So we've got really 2 delta x over delta x. And these cancel out, so we're left with the limit as delta x approaches 0 of 2. So what's the limit always going to be no matter what we have for x? It's going to be 2, which is what we said the slope was going to be right up there, right? Okay, now let's move on to the next one. So example 2 is about nonlinear functions. So now the graph is, the slope is going to be changing depending on where you are at on the graph, okay? So here's an example. Find the slope of the tangent lines to the graph f of x equals x squared plus 1 at the points 0, 1 and negative 1, 2. And we're going to see the picture. Okay, so here we go. Here is the picture. And we are looking at down here, right here. So we're looking at this stuff right here. So we want to know what is the tangent line, which is that blue one. Okay, it's this blue one right here at the point negative 1, 2, and we want to know the tangent line here at 0, 1. So what we're going to do is we're going to be able to find those at different points along the graph. Okay, and we can use limits to do that. We can use derivatives to do that. So the first thing we're going to do is we are going to say that the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Okay, that's the general form. Do we really need to write all of that? No, but that's the general form that we're going to write, that we're going to use to be able to solve this. Okay, so now what we're going to do is we're not going to worry about these specific points right now. We're going to just see if we can change this up a little bit, simplify some stuff, and see what happens. Okay, so we're going to say the limit as delta x approaches 0 of, and it's going to be parentheses x plus delta x squared plus 1 minus x squared plus 1 all over delta x, right? That is the right thing because we have this stuff is going in for this function. So it's x squared plus 1 and x squared plus 1. I'm going to put this in parentheses again so that way I remember to subtract the x squared and subtract the 1. Okay, so next I'm going to do is instead of rewriting this all, I guess we could, limit as delta x approaches 0, I'm going to use FOIL to go through and do x squared plus delta x squared. So that is our x plus delta x squared. So it's going to be x squared plus 2 x delta x plus 1, right? That whole thing, minus x squared minus 1. Remember, I'm distributing that 1 here, so that's why it's a minus 1. All over, oh, and you probably can't see that too well. And it does seem like this is a little laggy here today, so it's not keeping up with exactly what I'm writing. And let's get this to be nice, and there we go. Okay, now, what we can do is see if we can do anything. X squared minus x squared cancels out. Plus 1 minus 1 cancels out. So we're left with the limit as delta x approaches 0 of 2x delta x over delta x. Since we have all multiplication, we can cancel those out, which leaves us left with the limit as delta x approaches 0 of 2x. Okay, which really tells you that the slope is going to be 2 times whatever the x value is. Alright, so if we go back through and let's just look at these, the x value for this one is 0, and the x value here is for negative 1. So let's say, what's the slope at 0, 1? Well, I put in 0 for x, and I get 0. Okay, what is the slope at negative 1, 2? Well, I plug in 2 times negative 1, right? I'm going to take this thing, 2 times x, 2 times negative 1, and the slope should be negative 2. If we go back and just look at that picture real quick, that should be correct. So if we go here, does the slope look like it's negative 2 at this spot? It does. Does the slope look like it's 0 at this spot? Yes, it does. Okay, so that is how you do one with a non-linear function. Alright, now we have example 3, and now the computer is working a little bit faster again, which is very nice. Okay, so it says find the derivative of f of x equals x cubed plus 2x. Now you remember that a derivative really just means find the slope. That's really what we're looking for, find the slope. There are several different ways of writing it, so I'm just going to write it as f of x with the primes. We're going to say f prime of x is going to equal, we're going to say the limit as delta x approaches 0, and I'm going to write this again just so that way you get used to it. You don't have to write this every time, but it definitely helps with the beginning part of it. We're going to say f of x plus delta x minus f of x all over delta x. Okay, let's plug in everything we know. So we're going to say this is going to be the same as the limit as delta x approaches 0 of x plus delta x cubed plus 2x plus delta x minus x cubed plus 2x. Put this in parentheses so that way you don't forget to subtract the second one, as I've done several times in other videos. Delta x in the denominator. Okay, if you go to the front cover of your book because you don't remember how to factor or FOIL or all that kind of stuff with cube, you should do that, and that's going to be the same as the limit as delta x approaches 0 of x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. I'm going to run out of room, plus 2x plus 2 delta x, and I have to keep on going here, so I'm going to have to write the rest of this on the next line. That's also going to be minus x cubed plus negative 2x, and that's all going to be over delta x. Okay, now let's get through and see what we can do to hopefully clean this up. First of all, I've got an x cubed, and let's use a different color here. That seems like fun. Let's use red. I've got an x cubed and a negative x cubed, so they cancel out. Good. I have, let's see, a 2x and a negative 2x. These are going to cancel out. And that should pretty much happen every time, because you've got one here, you've got one here. They're going to cancel out. Okay, so what are we left with as far as this goes? Let's see. We have the limit as delta x approaches 0 of 3x squared delta x plus 3x delta x squared plus delta x cubed. So I've gotten this one, and that one. And then I also have plus 2 delta x. Okay, so now let's take a look at what we should do from here. All over delta x. Now if you notice, This one's got a delta x, delta x, delta x, delta x. They all have a delta x in them. So I'm going to say the limit as delta x approaches 0. I'm going to factor out a delta x from all of them. So we have delta x, and we're left with 3x squared plus 3x delta x plus delta x squared plus 2 all over delta x, right? All I did was factor this out. So if I cross these out, they're going to be left with the limit as delta x approaches 0 of 3x squared plus 3x delta x plus delta x squared plus 2. Okay, so now we can look at this and say, since we're not dividing, now we can import this 0 into the delta x's, right? Because we did that in the beginning where we just said, it doesn't matter, there's no divide by 0 error, there's no zeros in the denominator, we're not dividing, so we can just put in 0 for all of these delta x's, which means that becomes a 0, and this becomes a 0, so we're left with just that part, 3x squared plus 2. So we can say f prime of x equals 3x squared plus 2. So if you want to find the slope at any point of this cubic function, you just plug in the x value, and you'll get the slope. Alright, there you go.